out from our sun. This is the giant of our solar system, Jupiter. Jupiter is gigantic. It's 2.5 times more massive than all the other planets in the solar system added together. It's also home to gigantic megastorms. Jupiter's high-speed rotation drives vast bands of counter-rotating clouds. Colossal storms build along the boundaries. And this is the biggest of them all. The oldest storm in the solar system. 15,000 miles across and over 300 years old. The Great Red Spot. Around the edges, turbulent winds rage at over 300 miles per hour.
The Great Red Spot is a giant vortex, meaning that in the case of the red spot, it has a high-pressure center with winds that swirl around the outer edge. So, in that sense, the Great Red Spot is a little bit like a hurricane.
A hurricane with a difference. On Earth, hurricanes feed off heat from the ocean. When they hit land, they start to die. So on average, they last only about a week.
Jupiter does not have land. Jupiter is a completely gaseous planet, and the friction there is very weak. And so a vortex, like the Great Red Spot, can last indefinitely. There's nothing to slow it down.
To keep going, all the red spot needs is a power source. On Earth, ultimately, that's heat from the sun. But Jupiter's 5 times farther from the sun than us. Heat from the sun is not enough to drive the red spot. Instead, Jupiter has an internal power source, its own immense gravity. In 1995, NASA launched a probe straight toward the giant planet's heart. It plunged into Jupiter's upper atmosphere at over 106,000 miles per hour. As it fell, the planet's crushing gravity ratcheted up the pressure. 10, 15, 20 times what we feel on Earth. Winds gusted to over 400 miles per hour. The probe gave out just 100 miles in, crushed by pressure and fried by the incredible heat the pressure generated. Had the probe made it deeper, it would have reached a vast silvery ocean. Intense pressures here turn hydrogen gas into a churning metallic liquid. Superheated